Hello students, I welcome you all to Engineers Academy. Do subscribe Engineers Academy if you are here for the first time. Now we are going to solve this problem from chapter 4 Hibbeler statics, and the problem says that determine the moment of the force F of magnitude 600 Newton about point A. So we have to find the moment of this force F about that point A. So as we know that the moment of a given force can be determined about any point by using the cross product. So we can say that the moment about point A will be equal to the cross product of the moment arm with the force F. So we have to define the moment arm. So we can take the moment arm from A to B or from A to C. Both will give us the same answer, right? So now it's up to you that whether you people choose this or AB as the moment arm, or you people select this RAC as the moment arm. So I will select this RAC as the moment arm. So that RAC, I will write that this is RAC and this is that force F. So to evaluate this cross product, we need to have the Cartesian vector representation of this RAC and that force F. So force F is given as the magnitude of the force F is given. So first of all, we have to find RAC, which is the position vector from A to C. So to find the position vector from A to C, we have to travel along the x, y, and z to reach that point C from point A. So to reach that point C from A, we have to travel 4 meters in the negative z or in the negative k. So I will write minus 4k. And then from here, we need to travel 6 meters in the positive x. So I will write plus in the positive I. And then 6 meters in the positive j or in the positive y. So I will write plus 6j. So this is the position vector from A to C. Then we have to find that force F as a Cartesian vector. So force F Cartesian vector, this will be equal to its magnitude times the unit vector from B to C, since the force is acting from B to C. So this is the unit vector from B to C, and this is the magnitude. Now we can write that the magnitude is 600. I will write 600, and the unit vector from B to C is the position vector from B to C divided by the magnitude of this position vector. So now we have to find the position vector from B to C. So we will again repeat the same procedure that we have followed for finding the position vector from A to C. Now we have to travel along x, y, and z to reach that point C from B to find the position vector from B to C. So from B, first we have to travel this distance from this distance in the negative k, and this distance, if we look into this circular rod, so its radius is 4 meters. So if it is making 45 degrees, then this angle is also 45 degrees, and this distance from here to here, this is 4 sine of 45. I will write that this is 4 sine of 45 degrees. So 4 sine of 45, so this is 2.282. So 2.282 meters. So from B, we have to travel 2.282 distance in the negative k direction. So let me write that this is 600 and the position vector. So from B, we need to travel 2.282 in the negative k. So I will write minus 2.282 in the negative k. And then once we reach here, we have to travel this distance. This distance is this 6 meters minus this length, right? And this length is the cos component of the radius, right? So we can write that this is 6 minus this, which is 4 cos of 45. So this is 4 cos of 45. So 6 minus 4 cos of 45 is the distance we need to travel in the positive axis, that is 3.171, or we can say 3.172 approximately. So this distance we have to travel this 3.172 meters distance in the positive I direction. So I will write 3.172 in the positive I. And then once we reach here, we have to travel 6 meters in the positive j. So I will write plus 6j. So this is the position vector from B to C. and now we have to find its magnitude. So the magnitude of this will be, this is 3.172 square plus 6 square and plus 2.282 square and under the square root 2.282 square. So there is one correction, this is 2.828. remember this is 4 sine of 45, so 4 sine of 45 is 2.828. so this is 2.828, right? So I will write that this is 2.828. So we need to travel 2.828 in the negative k, then 3.172 in the positive I, and then 6 meters in the positive j. So then this is 2.828 square. So now we have to find that magnitude, which is 3.172 square plus 6 square is 36 plus 2.828 square. This gives us 7.35. So the magnitude is 7.35. 7.352, and now we can write this like 7.352 here as well. So this 600 divided by that answer, 600 divided by that answer gives us 81.60. so this is 81.60, and now that force vector is 81.60. we need to multiply this 81.60 with the magnitude of each component, that is 3.172, 258.84, 258.84 I, and then 81.60 multiplied by 6, 489.6 J, and then minus 2.828, and this gives us 230.76. this is minus K. So this is the moment arm from A to C, and this is the F Cartesian vector. Now we can find that moment about point A using the determinant method. This is I, J and K, and that is 6, 6 and minus 4, the components of the moment arm, and then the components of the force F. This is 258.8, 489.6 minus 230.76. so this will be equal to, now we have to hide this and this, so this is and this will be plus I minus J and plus K, remember. So that is 6 into this minus this, right? So 6 into minus 230.76 minus 4 into 489.6, and this will be into I, then minus J, we have to hide this and this, so that is 6 into this, 6 into minus 230.76 minus this, minus 4 into 258.8, and then for K we have to take the determinant of this, so this is plus K, and 6 into this, that is 6 into 489.6 minus 6 into this, so that is 6 into 258.8. so this will give us the determinant. So instead of using calculator, I am going to use this Excel sheet which I have made for finding the determinant. So I will write 6 and minus 4, and then this is 258.8, then 489.6, and then minus 230.76. So this gives us 573.84 I. So 573.84 I, and then this is 349.36 J. So plus 349.36 J, and then we have 1384.80, so that is plus 1384.80 K. So this is the moment of that vector about point A. Now if you were asked to find the magnitude of this MA, so we can find it by using the Pythagoras theorem. We can take the magnitude of this MA will be equal to, so we need to take the square of the magnitude of each component, and then we take the square root. So if we find this, that will give us this magnitude, which is 1539.16. So I will write that this magnitude is 1539.16, and the units will be, since the force is given in newtons and the distances are in meters, so the units will be Newton meter. Similarly, the units of this will also be in Newton meter. So this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe Engineers Academy.